This version of the LotBot Base Project is going to be used to control a robot in my next two videos. I don't want to spend much time on this module in those videos, so I am going to describe the module's update in this video. I don't expect many views of this video except for anyone who happens to see the next two videos and wants more information about this module. The original LotBot Base project was developed to contain components that I like for both robot and drones as I develop them. And I prototyped it originally on the base of a drone, and it's described in one of my earlier videos on my YouTube channel, LotBot Robotics. I also produced videos on each of the components of the project, and they can also be found on my YouTube channel, including the update of that shows this previous version of the module. In the previous version of the module, I discussed going from an STM32 blue pill to STM32F401 or a STM32F411, which are both known as STM32 black pills. I also noticed that the height of that previous version would work very well for a robot, but the height would not. It would present different kind of issues for a drone. The current version is lower, and it contains two STM32F4s. Now I'm going to discuss some of the components and what they do, and show you it functioning to some degree as a demo. I have used different remote control devices to control robots in some of my other projects. Lately I've been using this transmitter that I got from playing with my drones and their receivers. But for this type of project, you can use almost any kind of transmitter and receiver. Since I have this capability, I'm using it now. But I've used other types of devices, buttons and all sorts of little potentiometer type things to control robots and drones. But that's what I'm using right now for this LotBot Base project. When I, in this case, load a program to one of these two black pills, since I only have one way of coming in, what I've done, I could put two different USB to serial adapters so that I can choose which one I was going to hook to the computer to download a program to either this one or this one. Instead, what I did is I have a single way of coming in, and I have two switches, one here and one over there, that change the RX and the TX from this black pill to this black pill, or vice versa. So when I want to load a program from the my Mac in this case to say this one, I will switch the switches on both sides for the RX and TX over, or the other way. Now, the reason that I've gone to two black pills is in one of my previous videos, I talked about how I could take a 16 channel from of data, different switches and gimbals and different knobs even, and pass that 16 channels of data to two different 8-channel receivers. So what I thought about was that if I'm going to be controlling something that's very time sensitive like a drone, I would like to just keep the gimbal portions of the data on one receiver and all the other information type information that I would be using to come in on the other receiver. So what I've done is I have one of these black pills processing the gimbals, this one, and the other one being sort of the parent-child relationship, processing other information coming, switches and things coming from this receiver, and also being able to take data and display it on one of these two displays. Of course, since these displays have the same address, I needed this multiplexer. So I also talk between these two black pills through I2C and using this I2C multiplexer. Okay, now I'm just going to show you just a couple things that I could do with the displays. As you see, the display on the right is coming from the right STM32 or the child, if you think of a I2C parent-child relationship where the parent is doing all the controlling. So the actual displays are coming from the left STM32, but the data is coming from the right one through an I2C connection to the left one, which is then using the multiplexer to send the data to this display. By the way, all of that communications is I've got explained in another video on the I2C that uses 2 black pills and 5 displays. But in this case, I'm going to be moving the left gimbal vertical, and you'll see that the very top number on the left side goes to 2014, and then if I move it all the way down to the bottom, it goes to 995 or 6. If you notice, it flips back and forth. There is a little bit of noise in the data, and I'm not sure whether it's coming from the transmitter or just in the receiver communications to the microcomputer. I really think it's in the from the microcomputer and evaluating that number, because I can disconnect or I can turn off the transmitter, and the last data that was in the system will still come back and flip back and forth like that. But if I move it up, it does go all the way to max. And the same would happen if I go over to the horizontal position. You notice that it goes to max. If I go to the left, in horizontal, it'll go to a small number. And if I go to the right, right gimbal, you see it's going to a max position. If I go down below, it's going to a lower one, or sideways, it goes to a lower one, or to the right, it goes to 214. Okay, the other thing I could show you is that if I use the knobs, I could start showing maintenance functions on the left display, such as calibrating gimbals or turning motors on or off. Now, one other thing that I could do is I have a function that I could select through the knob on the transmitter, and it'll allow me to set these 2 wires as an external I2C, so I can have those interfaced to another black pill or some other function. In this case, in my next 2 videos, which is a single project that's going to be in 2 parts, I do use these 2 to communicate to a third black pill, and that will be to control some stepper drivers and some steppers that are going to that are used in a robot. So that's going to be a very interesting, at least interesting to me, a robot project where I'm using this communications to actually control that robot. The two wires I was talking about from I2C, the external wires, this would be a function that would make them active. And if they do become active, there's other functions that become disabled. Now, one interesting thing that I can show you is that if you're using this in any kind of an active environment, you may not, you may want these displays for maintenance and things, but you may not want them. You may not want them on here when you're flying a drone, so you can just take them off. These things are on headers, and they come right off. The same with the SD adapter, and then if you put them back on, if you reset it, then everything comes back to normal again. However, if you notice there is no data coming in, that's because the I2C is active. But if I deactivate the I2C, it becomes active again. I can also set the arm on. In a drone, you have a concept of arming it, and in this case, it's setting it, and then if I hit this, it'll arm it. That's just based on a switch that comes in from the parent. Okay, you get some idea that you can actually use these displays in a sort of a maintenance or information to see how the device that you're trying to use is working. Over here I have a SD card so that I can record different steps of a robot, and with the right code I can replay those so that I can have a robot repeat the same type of functions that it's doing. And hopefully I can show that also in my next project, which is going to be the follow-on 2 videos, part 1, part 2 type thing. Well, that's really all I can tell you about this communications and what I've got set up here. And if you have any comments or questions, or if you want to do any kind of discussion, or if you want to wait until you see the next project, feel free to put comments in and I'll be responding to them. Thanks for watching.